Good afternoon, everyone, and thank you for joining us today for our webinar, Complete Your Roadway Characteristic Data and Prepare for MIRE. Today, members from the AppGeo team, our co-hosts and project team members, Works Consulting, and management staff from Arizona DOT will present the drivers, outcomes, and key aspects from a multi-year effort, the ADOT Roadway Characteristic Inventory Project, or as we like to say, the RCI Project, to build out ADOT's roadway characteristics and prepare them for MIRE. My name is Peter Lemak, and I'll be the webinar moderator for today's discussion. A quick background on me. I'm a GIS consultant here at AppGeo and a member of our GIS transportation team. I've been with the company for 8 years, and over that time I've supported several DOTs leading projects to modernize right-of-way and extract HPMS and MIRE roadway characteristics, and I'm currently the production manager on the RCI project. Now, before we get started, just a few notes. This webinar presentation is brought to you by Applied Geographics and is part of our educational webinar series. If you are interested in other topics from imagery to NG911, you can catch up on past presentations in our Learning Hub webinar library. Now, currently you're all in listen-only mode. So if you have any questions during the presentation, please put them in the questions box in the control panel. We'll monitor them throughout, and then we'll answer them at the end of the webinar. And we hope to get through all the questions, but if we don't, we'll make sure that we send an email with answers to all the questions that were submitted. Now, just another note, this webinar is being recorded, and we'll share it along with the slide deck for you to share with others or review yourself. Now, for our presentation today, AppGeo and Works Consulting are very excited about the presentation, as we're joined by Patrick Whiteford, the Geographic Information System Manager at the Arizona Department of Transportation. Patrick has over 14 years of professional experience in transportation GIS, and he's been with ADOT for over 9 years. Patrick earned his master's degree from Arizona State University in GIS and is a certified GIS professional. He's knowledgeable on the intricacies of linear referencing systems and is an advocate for the use of geospatial technology and the project champion and ADOT lead for our RCI project. Now, we're also joined by our co-host and project team partners, Ryan Blum from Works Consulting. Ryan has been with Works Consulting since its inception in 1999. In that time, he has become the principal geospatial technology and data manager for Works Consulting's Centerline GIS and LRS solutions. He has worked with and developed solutions for many different data systems and customers over this time. Ryan has been instrumental in the design and development of many Works Consulting software solutions, focusing primarily on geoprocessing and UI design. He is currently serving as project manager and technical lead on various projects, and is also serving as HPMS supplemental services support on-site with ADOT GIS Group, where he leads Works Consulting assistance in implementing roads and highways. And finally, we have Caitlin Schneider. She's a senior GIS analyst who has been with AppGeo for 3 years. As an experienced analyst, business analyst, and certified Scrum Master, Caitlin has provided a wide range of support functions for AppGeo's GIS team. Her expertise in detailed spatial data collection and processing methods, Python scripting, spatial and non-spatial data integration, quality control and data documentation, and her efforts during the HPMS reassessment have helped drive statewide data modernization efforts for several DOTs, including ADOT. Now, the RCI project is managed and led by Applied Geographics, and we're joined and supported by several key organizations. Works Consulting and their knowledgeable and skilled analysts have provided meaningful insights into the ADOT systems and geospatial data models. Mill Geospatial, a consulting firm in Arizona, provides significant data extraction support, and One Spatial has developed key CAD to GIS extraction routines using their One Integrate product. All 4 project team partners have provided key services on the RCI project, which have resulted in successful outcomes and have met ADOT's vision. Now, during today's presentation, which is broken into 4 parts, you'll hear from these key members of the RCI project team as I present again the drivers, key activities, considerations, and successes of the RCI project. In the first part, part 1, the road less traveled, we'll hear from Patrick, where he'll present an overview of the project, why the effort is so important, and how it came to be. In part 2, walking the roads, Caitlin will present and discuss the activities, starting with a strategic assessment and review of ADOT systems prior to the multi-year extraction effort. Part 3, how safe is it? Ryan and Caitlin will explore MIRE and will discuss how the project team set ADOT on a path to prepare for MIRE 2026. And then finally, in part 4, does the sun really set in Arizona? Patrick and I will discuss the future of ADOT and the next steps of our project. So let's start at the beginning, the road less traveled. Patrick, at a high level, the RCI project is an effort to help ADOT support key federal highway programs, Arnold, HPS, and MIRE. Can you discuss the importance of these programs at the federal level and the state level? And then, how does the effort support these programs? How do they benefit Arizona DOT?
Yeah, absolutely. Thank you, Peter, and welcome everyone. I'm really happy to be here. It's nice to see so many familiar names. So for me in Arizona, the biggest thing that when I first started thinking through this project and looking through the data was I really wanted this to be an emphasis on the data itself. As ADOT is becoming more and more is more and more of a data-driven decision-making agency, you need to have good data, of course, to be able to make those decisions. And one thing that always amazes me is with all of the different state agencies that I know, we all have very similar reporting requirements, whether it's HPMS or MIRE or Arnold, what have you. But we all get there from a very different way. And so I wanted to kind of build a standard here with data as the backbone to support not only our federal reporting, but other internal reporting requirements that we had within the agency. And so, with that, looking at, and then also looking at, how can local outreach be done, and how can we build an update mechanism or a supply chain, if you will, to ensure that this data stays up to date long term. So that was a big driving factor, was trying to get the data in good shape and so that it could support many different federal requirements.
So Patrick, being able to collect that data and report that information to Federal Highway is critical for your operations. Now, our project had started back in 2017. So can you give us a sense of where ADOT was prior to those efforts in terms of completeness of your roadway characteristics inventory and your ability to meet requirements?
Yeah, most definitely, Peter. So for the ADOT data, we had very good data quality on the state-owned system initially prior to this project. And a lot of that was driven by HPMS requirements. And as HPMS has evolved throughout the years, those requirements have changed, and now there's more and more data elements that you need to have off the state-owned system. And so seeing those gaps within the data was a big part of the driver for this project. And I saw an opportunity to start collecting data off the state system for a number of different external and internal business needs. And prior to this project, ADOT was leveraging an internal tool that was used to manage our roadway characteristics data plus our linear referencing system. And in 2014, we did transition from that product into Esri's Roads and Highways to manage our linear referencing system. And with doing that transition, it opened up a whole new world for us as far as our ability to start bringing in other systems and other data products into a singular system. Okay, whether that's from bridge or traffic or pavement, but bringing them into to a common source using location-based information was a huge part of a catalyst for starting this project. So other things that came of this is just there are a lot of internal data requests that we get from management, and historically we weren't able to really answer those questions without a huge data effort to fill in the blanks on these things. And so there are a lot of kind of little things that happened related to this that culminated into this, developing into this project. And it was again all data driven for us. And then lastly, data governance was very much of a wish for ADOT prior to this project. And we were always chasing each other's tails. The right hand didn't know what the left hand was doing. And so by identifying some of the low-hanging fruit, something as simple as developing workflow documentation or developing better metadata. And then this might sound really trivial and simple, but really honing in on the roles and responsibilities within the agency has been a huge benefit for us and has been also a part of this project.
So in addition to those data gaps and the seeming lack of governance in some areas, what were some of the other challenges that you faced, or as I know that you like to reframe them, opportunities?
Mm-hmm. Absolutely. So I'm always very big about taking a positive spin on challenges and really turning them into an opportunity. And for all of my state DOT friends on the call, I think we'll all chuckle about this, but the whole idea of breaking down silos, we all have siloed workflows within our respective agencies. And the notion had always been, let's break down these silos and bring everything into a singular product. And that's not always feasible. It depends on, your agency largely. And also the climate of your agency. Sometimes when you talk about those things, like you're not gonna get much feedback from your management. So instead of breaking down silos, the idea of starting to connect them using location-based information, specifically the linear referencing system. And then that transitioned very nicely into how can we do some targeted outreach with our business units that leverage data and identify customers that are using GIS now and other customers that could use GIS in the future. And then once that happened, transitioning that into prioritizing what roads do we need to extract. And so with that, identifying urban and rural roadways, and then specifically down into their functional classifications, was a huge help, because that helped my management understand that it's not this nebulous amount of data that needs to be collected. It's now broken up into sizable chunks that we can show progress throughout time and build metrics to set goals with. And then lastly, even before starting this project, I was thinking, okay, so let's say we collect all of this data, but how do we maintain it for the long term? And so that's where One Spatial and AppGeo and Works were able to come in and help identify tools and also functionality to help us fill in the blanks related to these things. So that way we could build something once and use it many times.
Right. So you identified these challenges, and based on those challenges, you came up with the vision for the RCI project. How did you justify the investment into a large scale project? I mean, the one that we've been working on has been going for 4 years now.
Yeah. So before kind of getting on with this project, I really wanted to do what I call a strategic pause, changing out the tire, if you will. In ADOT and all Arizona agencies, we have been really focusing on process improvement, and really looking at the steps in the workflow and trying to find bottlenecks and challenges related to those things. And with that, you have to have good data to be able to do those things. And so for me, it was trying to align a lot of our business needs with these federal reporting requirements. And so I talked with a lot of our internal customers to understand what their pain points were, whether it was the traffic team, the safety team, pavement team, so on and so forth. And that way, as we collected this data with this project, how could we help those individual teams and align those needs, so that way we're collecting this data and it's supporting multiple teams, not just the planning team where I reside. And so again, that relationship building, more of the soft skill aspect of this is where I kind of came in. That way we could collect it once and use it many times. And again, thinking about sustainability of this data, how can we look at, other agencies that might have benefit, our local municipalities, our cities, our COG and NPOs, to look at how can we consider the sustainability of the data. So that way we're not having the same problem 5 years from now after we've spent a lot of money to collect the data and now it's all out of date. We need to have that feedback loop associated with it. And then lastly, just kind of aligning everything with our federal requirements, whether it was HPMS and MIRE, was a huge part of what we wanted to do here to help justify the change.
Great. So Patrick, we're going to discuss some of the key activities in a few minutes, but could you give everyone kind of an overview of what those major tasks and areas that you wanted the project team to focus on for the project?
Yeah, most definitely. So the real meat and potatoes of the project was the actual data collection, the extraction itself. And that was using a variety of different methodologies that we're going to go into in a little bit. The other piece was the implementation of a data supply chain using the One Spatial technology, which helps us to collect and extract data for things like right-of-way, roadway characteristics data, and updates to the linear referencing system that will eventually go back into Arnold. And then with that was, developing validations and quality QC, checks to ensure that when we've collected this data, how do we ensure that we don't produce data shrapnel, we don't introduce data shrapnel into the data itself? So developing, rules related to those things and validations, not only from one feature, but from feature to feature. So the relationships between those features was important to us. So for example, you can't have an interstate, something that's functionally classified as interstate that has a speed limit less than X, for example. And then, doing a gap analysis related to our MIRE elements. With when 1.0 came out and then 2.0 came out, we wanted to make sure that that database schema that we had aligned properly with the MIRE. And then lastly, and very importantly, can't be understated here, but typically because it's lost, is how do we train my staff for the data maintenance and documentation of these things, so that way that library of knowledge doesn't go away if someone decides to leave the agency.
Great. Well, thank you for that overview of ADOT and an introduction to the project. So at this time, we'll turn it over to Caitlin, and we'll explore some of the work that's been done. So Caitlin, prior to processing, Patrick saw that a strategic pause, or as you and I viewed it, a strategic assessment of the ADOT systems and databases was a way to set ourselves up for the long-term success of collecting and maintaining data. What did the project team do during this strategic pause to set ourselves up for that long-term success?
Yeah, absolutely. So the goal during this time was to get a really good understanding of ADOT systems and current workflows. ADOT was already doing a lot of things really well, such as good documentation and had a really solid schema. But I think there's a lot of value to coming into something with a fresh set of eyes and an unbiased opinion to make suggestions and ask questions when you're coming at it from a different angle, which is what we tried to do during this time as we were evaluating the existing database and processing workflows. We also kept in mind recommendations that were included in the HPMS reassessment, which we were helping write at the time. So that way we could help tailor our recommendations to ADOT so they stayed current on any potential HPMS changes. Taking this into consideration and doing the strategic assessment really allowed the project team to develop a strong set of recommendations that could then be evaluated and incorporating into the processing workflows as the project progressed. So the recommendations themselves fell into 4 general categories, and we tried to make these comprehensive to encompass all aspects of the extraction workflow, and at the same time come up with standards that could be easily adjusted if any outliers came up. So we looked at the database schema updates, changes to the roadway characteristics editor or RCE environment within roads and highways, and processing workflows to reduce redundancy and improve efficiency, and incorporate MIRE and data lifecycle management into the existing ADOT system. I'll touch on some more concrete examples in a minute, but I think from an analyst perspective, this really had the biggest impact on reducing redundancy and increasing efficiency. I think these are things that we always want to strive for in our day-to-day workflows. So having something specifically targeted for that has been really beneficial for the analyst. So for example, before we started processing, we evaluated the attribute sets that we would use within the RCE. We went through each data item and limited this to only the fields that we were accountable for extraction. So that way there was less confusion over what the required fields actually were, and no one was accidentally trying to create any bad data in a miscellaneous field. This did include adding and adjusting some fields that came out of the database recommendations, one of which was a competence field. This is both a communication mechanism and a QC tool. So an analyst can use it to mark something as low confidence or indicate it's a new scenario that they've never seen before. So that's a signal to someone doing QC that they need to make sure everything is captured correctly. Another key recommendation that really helps, excuse me, from a management perspective is the RCI tracker feature class, which is shown here where each color represents a different analyst assigned to the route. This is a feature class within the RCE interface that analysts can query against to see what routes are assigned to them. So they have a list of routes they can continually work through. And that way no one's stepping on any toes or anything like that, trying to grab routes. This also allows them to indicate which routes are in progress. So if someone had a really long route, they weren't able to finish in a day, they could use the fields within this to indicate that they were currently processing it and then update it to show when it was completed. So that way the management team can track more easily track what's completed, in progress, or done. This also allows analysts to add comments, which is really useful, just kind of keeping track of the bigger picture. So if a route was skipped for some reason, like it was under construction in both the aerial and street view imagery, so the analyst didn't want to go ahead and capture it, that can be noted in comments. So you don't have to track back in and dive into the route and try and figure out why it wasn't completed.
Great. So once we made those updates based on those recommendations and we implemented that RCI tracker, our team started the extraction process. Can you give us a sense of what that process really entailed? You know, what did we extract? What were our key methodologies?
Yeah, absolutely. So in terms of extracting, we were responsible for extracting 36 data items on non-state-owned roadways. This included creating new events as well as updating existing ones that may have been on the route. So a key part of our workflow is evaluating what data items are currently there and updating them if necessary to reflect the current characteristics. So that way it's a core part of our data lifecycle workflow. So for example, if there's an existing through lane record of 2 lanes based on the current, if there's an existing record of 2 lanes, but based on current aerial imagery, an analyst sees that it's been widened to 4, the analyst can then update that record to account for this. So that way the data lifecycle is a core part of the day-to-day processing workflow and not something that's done in bulk after the fact. After all the data items have been extracted, the analyst will then do an intensive self-QC to make sure nothing was missed, and then run some validations within the RCE to check for required fields. And once they've finished all that, they'll go ahead and mark it off as complete within the RCI tracker so we can monitor progress. In terms of the source data that was used for extraction, we explored a lot of different options to try and find out what would work best and make this most efficient, and landed on using both street view and aerial imagery. Some data items like speed limit, you just can't determine that from aerial imagery alone. So we wanted to try and make that as accurate as possible. So when they're extracting, an analyst will walk the route in Google Street View and evaluate that against the current aerial imagery to capture all the needed data items.
Now, one part of our project effort was to continuously review the existing documentation, create training materials, as Patrick said, to support his analysts, and then standardize the reference material for current and future analysts. Can you give an example of some of the ways our team really enhanced the documentation, and what were some of the immediate benefits to you on the processing team?
Definitely. So a key part of this is updating that documentation continually. So things are refined and changed over time, or as analysts come across scenarios that we've never seen before. We've often found that these unique scenarios or scenarios similar to them can come up again as we extract more and more. So that way, because we do this as we go, we're now more able to quickly and easily answer questions and point people to the right place in the documentation because this is done as we go. So it kind of cuts down on that time. ADOT had a lot of really good documentation in place in their existing OneNote. So we were able to build off this. Some of it was simply adding fields that had come out of the schema recommendations or making sure the processing workflow was really clearly defined for a particular data item. A really good example of this is a golf cart lane that we found during extraction. Because of the way we built out the schema during that strategic review phase, there was a standard in place where analysts knew this could be captured as an auxiliary lane. And so we were then able to update the domain type for this so it can be captured specifically. And then we're more able to easily account for these kind of outliers and document them so analysts know how to handle it when it comes up again. So really all the data and processing and training documentation is updated continuously in this iterative manner to account for these new changes instead of us having to do a bulk update to that at the end of the project.
Well, Caitlin, that's a good thing that we've been documenting continuously, because I don't think any of our Boston-based analysts have ever seen a golf cart lane in our lives. So, so we've been doing about 4 years of extraction with ADOT. As you pointed out, we've made a lot of changes to the database, to the processing methodologies, documentation. How do you think the extraction process went overall?
I think it's gone really well, particularly as the team has gained more experience. This whole project is very much a team effort between Works and AppGeo and MIL. So as people get more familiar with these processing workflows and become more confident, they become much more efficient. So in phase 1 and 2, as the graph shows, I think there was a bit of a learning curve, but now we're almost done with phase 3 and we've hit over 5,000 miles. So I think that experience is definitely showing in the total number of miles that we're completing at the end of each phase, as well as the individual mileage that analysts are able to complete each week.
Great, thank you. So roadway characteristics, they're important for HPMS and internal reporting for ADOT. But looking ahead, we also know that MIRE is poised to be a significant federal reporting requirement due to its importance in roadway safety analysis. Now, while the bulk of our team focused on extraction, some of us began the process to incorporate MIRE into the ADOT system and prepare ADOT for 2026. So Ryan, can you give us a high-level overview of MIRE and safety and what that means for ADOT?
Sure, Peter. So MIRE is short for the Model Inventory of Roadway Elements. And what it is it's basically a bunch of safety-focused roadway elements or data that helps the states and other agencies and other groups make good decisions based on good data. So the whole goal of MIRE is really to get to the zero deaths initiative that the whole country, different cities and states have been trying to push, where we have transportation systems where we have very little, if zero, fatalities or major incidents. With that said, the MIRE standards, they put together what's called FDEs, and these are fundamental data elements. These fundamental data elements are what MIRE is requiring all the states to have by 2026 so that they can be used in nationwide, and also everyone will be on the same baseline. ADOT wanted to be ahead of this, and so they started looking at MIRE in 2017 when we started the project to make sure that we had plenty of time to make sure that everything was appropriately planned, that we'd make our 2026 deadline. And we did this by looking at the MIRE FDE standards and making sure that they were taken into account during the project.
So as you said, our main focus was on MIRE, either reviewing the criteria, adjusting the database to accommodate those FDEs, and really incorporate them into the GIS database. Now, with every schema change, we needed to account for how to process and extract the data in order to close those gaps. So what did that FDE review process look like, and how do we start preparing ADOT?
Okay, so ADOT really wanted to look at how do we get to the FDE compliance, maybe beyond the FDE compliance, and what is the level of effort that it's going to take to do that. So as a team, we decided the way to look at that was really to look at a bunch of different types of gap analysis, looking at gaps within the existing data sets that they had, schema changes and schema gaps that were there, and collection standard gaps. So things that were in collection that wouldn't quite make the MIRE requirement, ways that we could make those changes. So we did that. We began digging into all these different things, the schema, the data, and everything else. We found that ADOT was pretty much mostly incompliant with many of the FDE overlap, with the FDE requirements. And this was because MIRE 2.0, when it came out, they did a push to make sure that it overlapped as much as possible with other federal requirements, like HPMS and other things. And ADOT has a lot of internal, they've done a really good job of trying to set their own standards internally and make sure that they have the data they need to make good data-driven decisions. So we didn't have a big gap between getting the minimum FDE requirements for MIRE and what ADOT was already pursuing or trying to pursue. We looked at those data gaps in 3 different tiers. MIRE 2.0 has 3 different tiers, and we went into a whole bunch of different types of analysis levels by tier and by functional class and by whether or not it was functionally classed, et cetera, et cetera. Caitlin has more of that in a couple slides. But we delivered all of our findings to ADOT. And when we did that, we did it in a couple different ways. We gave them a report, a recommendations report, basically gave them the status of the state, if you will, as they stood for MIRE compliance, and the places that we needed to make change to hit our goals. We also gave them updated schema and extraction workflows. So it says to get here, we have to here's the schema changes that'll need to be made in your data. And here's the functional workflows that will allow what has previously been collected to now be collected to MIRE standards. And then, and Caitlin again will go over this later, we did a really detailed FDE gap analysis script that looks at each individual data set in all of these different networks to really determine what was missing at any time throughout the project.
So I do want to focus first on that first part, looking at the schema, though you did say that ADOT was in a good position, we did find some areas where we could make some recommendations for them to improve. Can you talk through a couple of the FDEs that we presented back in our report?
Yeah, absolutely. So if you look at the slide here, we put up a couple of quick examples. A couple of the FDEs, FDE 121 was the intersections junction traffic control. And I think the key here was the recommendations. So this is a good example of where we came across one where we were in pretty close compliance to what MIRE needed. However, ADOT really wasn't too concerned about railroads, pedestrians, and yield signs up until we looked at this MIRE compliance. So our recommendation at this point was, you're already collecting this, we're already doing a good job. We need to add a couple things to your domains and change your workflow so that it'll be compliant. The other one that I think was kind of interesting to point out was the FDE number 55, which is median type. In this case, again, there was a lot of overlap between what MIRE was asking for and what ADOT had, but ADOT records this data in two different sets, in medians and painted medians. So together, it would meet the MIRE requirement. And I think the interesting part here is in the focus consideration section, where we talk about the fact that we were collecting medians, we were collecting all the standards that we need, but the one thing that MIRE had that we didn't was we had a non-passable barrier, but we did not explicitly say whether it was a positive barrier or a negative barrier. So adding a little bit more detail to pre-existing data and merging two data sets is really what got us through that.
So as you said, the schema review was just one piece of the report in understanding, ADOT's FDE gaps. Now the other part was looking at the data itself. So Caitlin, I know you put together a pretty significant gap analysis script. Can you walk us through that and how you figured out where those gaps were?
Yeah, absolutely. So we created a script that we can run at any point during the project to evaluate progress for MIRE. This output is able to help communicate to ADOT what gaps exist for specific data items, just in terms of how close ADOT is to having full network-wide coverage for each of those data items, as well as areas where that data item may exist, but is missing attribution that's required for any analysis. So technically, to do this, we used Esri's overlay router events tool to get a dynamically segmented output for each data item that we can then query against to find the extent of the data item along the network, as well as find those areas where the data item, again, is existing, but is missing that required attribution. So once we've identified those areas, we can sum the total mileage and write that to an output table that has the data item name and those mileage numbers. Those numbers then tell us how much mileage was gained from the last time the script was run to now, so that delta number, as then how close we are to 100% network-wide coverage.
So once you ran the script and you got all the values, how did you present that data to Patrick? And how is the way that you presented it to him important with respect to MIRE?
Sure. So in terms of the actual output, we provide this in two different ways. One that's an overview of the results for functionally classified non-local roads, as well as local roads, which is that table there on the right-hand side, as well as additional tables that are broken into the categories shown there on the left, which are representative of the data item extents by functional classification, if the roadway is paved or unpaved, and if it's state or non-state owned. So we wanted to provide both a higher level and more granular view to help ADOT stakeholders understand the current coverage extent, as well as align with MIRE reporting requirements. So that way ADOT could more easily prioritize what they needed to focus on next.
Great. So keeping MIRE in mind, I want to quickly reflect back to Patrick's original goals and visions, which is, having tighter integration and coordination between other data producing and data consuming departments, specifically the safety group. So Ryan, one data item that we focused heavily on to support that future coordination was the Junctions data set. Can you tell us a little bit about that processing effort and what those benefits are to ADOT?
Yeah, absolutely. So when we started the project, when we started looking at MIRE compliance, we found that the ADOT safety team had already started to make a push to build out their MIRE needs within Junctions. And they did this away from what was already currently there as far as the junctions data set that ADOT had. So these two things were two separate data sets. One of them was newer and had MIRE compliance. One of them was a lot more comprehensive, but didn't have the MIRE compliance that was needed. So when we did this analysis, we determined that these two data sets really needed to come back together and serve as a, bestest, mostest, if you like pizza, junction set. And so to do that, we had to look at that and figure out how those two were going to come together. We use the GIS and we use the LRS to do that. And so to do that, what we did is obviously, like I just said, we have to merge the two masters. So first thing we looked at is how do we bring these together? And we tried to look at it as comprehensively as possible, not only spatially, but looking at its LRS definitions, as well as the legacy junctions data set had some location and offset static data information. So not spatial, but information about space. So we used all three of those sources, right? The actual shapes of the two junction sets, the LRS definitions of them, as well as the written definitions of these to try to determine what was likely match, what likely wasn't a match. And the goal here was to spend as little time and money as possible doing this so that we could come up with a great data set without without spending an exhaustive amount of time and effort. So if we look at what we did there, once we come up with the merge strategies, right? We came up with likely merge strategies. We then looked at, okay, because of limited budget and time, we looked at what are the level of efforts for different junctions. So what is the expected chance? Is this a really close match? We think the level of effort is going to be very low, or is this, really like we couldn't come up with an automated way to guesstimate what the answer is going to be? This is going to take a lot of review. We also looked at ADOT data priorities. What other things did ADOT want to use junctions for? And therefore, out of all the junctions in the state, which were the most important ones to get synced together fastest? We looked at functional classification, rural, urban, national highway system, things like that. And then we created a process. We realized through this analysis that we were going to need our analysts to review at least a portion of this data set to make sure that what came out of this was a comprehensive and correct data set rather than just a data set. So we came up with a process where the analysts could take the time to review the junction, but not actually have to make the edits. So after we gave them the weight and we gave them a suggestion of what we thought might be the case, they could quickly agree or disagree, basically reorder and say, no, this should be something else, or yeah, your guesstimate was correct. And that allowed us still to use as much automation as possible at the end to make sure that we used as little budget and time.
Great. Well, Ryan, Caitlin, thank you both for the overview of the MIRE process and the junction extraction process. So to date, there's been a lot of good effort in terms of extraction, collection, and assessment of the ADOT system that really put our team in a position of success for internal and federal reporting. I'd be really interested in hearing from Patrick on what he sees as the next steps for the project. So to kick off this final portion of our presentation, Patrick, I do have a quick question for you. As an East Coaster, I gotta know, does the sun really set in Arizona? Or for our GIST professionals on the call, what's the next step in the ADOT lifecycle?
Yeah, thank you, Peter, and I love the Calvin Hobbes reference. So huge accomplishments related to this project, and so far in the phases that we've done, we've collected over 9,000 miles worth of roadway, and a fourth phase of the project is going to be started in the upcoming months. And we're going to continue to align our data with the MIRE requirements and continue doing that extraction down to the locally functioning classified roadways, and that way we can fill in as much gap as possible related to our data. Start incorporating non-fundamental data elements, the non-FDEs, into our data to start filling in those blanks as well, to start getting ready for the 2026 deadline. And some things we're going to start. We're looking to implement data reviewer from Esri that will help with us some of our data review checks of our roadway characteristics. And as far as some other future things, I'd love to be able to start leveraging our route network as a service. That way we can we have, this network that incorporates many state agencies, local roadway center lines. I want to be able to host that back out to those individuals, and really continuing to connect the silos, via the GIS is something I'm going to continue doing, and just really trying to be a GIS or data advocate. Continuing to do just good data management practices, good data governance. And then lastly, not to forget that we got to continue talking with our constituents and continuing on those systems of engagement. I also plan to expand some of the processes that we have leveraged using the One Integrate tools from One Spatial. So big shout out to the One Spatial team. There's a lot that can still be done related to data cleansing. About every data set within our Roadway basically is really where I want to focus.
So as a GIS manager at a DOT, someone who put together this project, who had a vision, again, I've said it before, this has been a 4-year effort and it's still going. Why does an effort of this magnitude matter to you? And why would it matter to another manager at another DOT?
Mm-hmm. No, great question, Peter. And for me, as this process has evolved, I really wanted to continue planting for the future, if you will, and really an emphasis on the data. It's not uncommon to really look at to overly focus on the tools, but if you don't have good data to put into those tools don't mean much. And so really being able to set new goals and for me, being flexible to kind of change with the ebb and flow of the project was incredibly important. And so with that, some, kind of happy things that have come out of it, happy mistakes, I guess, if you will, have been, improved data visualization for our internal customers. And then, continuing to strive towards improving our emergency management. All of this data is being used by our safety team right now to help do analysis on and off the state-owned system. And, as I've said before, really an emphasis on, how do we sustain this data long-term? And then how can we build a culture of data scientists around this related to good data management, data governance? And again, being that advocate that, hey, listen, like GIS is a great tool. Let's leverage it for things. So for me, that's why it matters. And for my DOT folks on friends on the call, I'm sure that really resonates with you and will resonate with management as well.
Great, thank you. So as we near the end of our presentation, I briefly wanted to look at, Patrick's original vision for the project and to show where we've come over time. So our pre-project vision was really a focus on data extraction, preparing ADOT for MIRE, incorporating data supply chain into their system with a strong foundation of data governance. And 4 years later, what we've been able to provide has been enhanced workflows and documents to drive efficient processing. We've managed junctions and we've incorporated all FDEs into their workflows. And we've done things like set up significant validations to ensure that we have strong QC routines. And we've also provided a sustainability plan for that long-term goal and long-term success at the DOT. Now, what did we learn? Really, at the end of this project, it's a culmination of efforts that put many pieces together in order to drive ADOT forward and help solve their problems. So what we learned is that really it's more than just extraction, it's more than just processing. It's an effort that requires the understanding of the bigger picture from federal highway to the state to the local level, where we need to incorporate new technologies such as roads and highways. And we also need to update schemas and reflect the ADOT system to meet federal requirements as they continue to evolve. So with that, I'd like to thank everybody for being in attendance today. If you have any questions right now, please go ahead and enter them into the chat, and our team will answer the questions as time allows. So with that, I'll ask everyone on the panel to turn their cameras back on and unmute, and we can go through some of the questions that we have. And with that, I might need to ask Aaron if he's out there to help me, because I can't seem to get the Q&A to open.
Yep, we're here behind the scenes.
There we go.
Taking a look now. Yeah, feel free to keep on asking, as we have about 15 minutes reserved for our Q&A session here.
And Aaron, do we have any questions at this time?
Let's see, going through our queue here. We have one question. Do you have any examples of unique data visualization that your teams have done?
Yeah, I can speak to that. We produced a number of dashboards using this data to help replicate a lot of the commonly asked data requests that we get. So for example, the HPMS travel and extent report that we get every year from UPACs, it's a real simple table that has certified public mileage, or centerline mileage, lane miles, and VMT. And it's very common for us to get questions on, VMT, vehicle miles traveled, but by a specific geography. So by a county or district or city or so forth. And so being able to take that data and dissect it, we processing it, and then visualizing it was a huge step in the right direction for us, because it mitigated a lot of ad hoc requests that we had, and we weren't able to really do that effectively prior to some of this work, just because the data just wasn't filled in off the state system. So that's just one example. And we also put a lot of these dashboards on our ADOT website and our intranet and internet. So that way we can really promote that self-service mentality, allow management to get to the products they need themselves to answer their own questions.
Thanks for jumping on that one, Patrick. Just one or two more questions here in the background. This one has to do with the functional classifications. Do those functional classifications roll up to any outside mapping providers, such as Google, OpenStreetMap, etc.? Any comments on how the functional classifications are used outside of the organization?
Can you ask the question again?
Sure. I think the question is around the roadway functional classifications, and if ways in which that data can roll up outside of the organization.
Mm-hmm. So I think that to answer that, it just, so for us, functional classification helps us in a variety of different methods. It helps us with our planning aspects. It's used heavily for the purposes of defining the federal aid system. And so for this project specifically, we used it heavily to help prioritize our projects. For external processes, it is used heavily within planning, with let's say if you're a part of a city or a COG and NPO, the state agency typically owns that process and works very closely with those agencies to make those updates. And depending on what that classification is, there's certain roadway requirements related to how that roadway is built. So it involves a lot of the planning aspects of it. So I hope that answers the question.
Yeah, I remember in my time working with cartography, you have it's one way of doing line symbolization, but it sounds like there's just so much more behind the scenes than the thickness of a road, right?
Absolutely.
So we have a few more questions coming in. Thanks everybody for keeping up the good energy. Here's a couple from an anonymous attendee. What measures do you take to reduce data entry errors, and how often and what percentage of manual spot check for potential data entry exists? So kind of that QA/QC process, if anyone wants to answer to that.
Caitlin, do you want to jump on that one?
Yeah, absolutely. So for the first part of what measures do we take, I think the biggest ones are probably going to be the attribute sets edits. So that way they're really only having to enter required fields. Secondly, the validations that are run are a huge part of this. So we're able to validate, like, did you put in all the required fields? And then check for some business logic. Like Patrick gave a really good example of, if you gave a speed limit for an interstate, that's maybe like 45, that's probably not going to happen in the real world. So we can flag that and then go back and validate it. In terms of the manual percentage, I don't know if I can come up with a good number there, and Peter, feel free to chime in, but it is something we do. We can't spot check every single route just because we've done 5,000 miles, but we do try and make sure that, the extents are right. So that way no one's starting a turn lane like halfway up where it should actually start, that kind of thing. Yeah, Ryan.
Right.
Yeah, I think I can add to that just a little bit as far as internally. Caitlin, great answer, but I think the one other key part is we paid attention to analysts as well. So right, when a new analyst would come in, they'd have like a mentorship, if you will, right? Someone that was already well versed in what was being collected, kind of their main contact to ask questions to. And we would facilitate a manual review, usually between 10 to 15% of that person's work as it was starting. And then as the number of issues would come down, that would then become more of a round robin check. So as what we would have, instead of having one person check, we would have kind of round robin itself so that nobody kind of got out of sync with the overall needs and the overall great data. The other way that we try to keep data integrity, I think that was actually really neat, is we're 4 different teams across the country. Is we created a bunch of places where like a Google group, if you will, where the questions would be answered for all. So one person can answer a question and that answer would go out to everyone, and kind of make sure that we kind of kept in sync. And Patrick's got a great documentation set up. I know Caitlin mentioned it earlier, that really allows anyone to kind of jump into an encyclopedia of information, if you will, about any sort of thing. So a lot of questions, that was kind of the guidance there that could kind of keep everybody on task.
And just to chime in, with the upgrade of ADOT system from 10.3 to ArcGIS 10.7, we've been able to start the process of integrating Data Reviewer into the Roadway characteristic editor, which means that all those validations that we've built over the past several years that we typically run in bulk at the end of a processing session, analysts will be able to run once they've completed the route or the segment that they've done. So that they'll get that immediate feedback of, what didn't pass validation, where's the error, and how do they go fix it before they move on to the next route. So that's something that we've been wanting to implement, and we're now at that point where we can.
Very good. We have a couple more questions I want to make sure we get to, but feel free to keep asking. We have one here. For the data extraction process, have you used any AI or ML machine learning algorithms, or is it a completely manual process? And they're interested to know more about AI, ML, if we have dabbled in any of those.
Yeah, I can answer that question. So it's definitely something I'd like to be able to do in the future. It's something my management has asked me about in the past, as far as just high level, what would AI do for us as an agency? What can we get out of it? For what I've seen, the technology just quite isn't there yet to be able to identify something like a stop sign or something like that. It always requires some sort of manual, putting eyes on the data to validate it. So that's something. It was a consideration prior to starting this project, was how could we leverage AI. It didn't. I still have yet to see a real good, something that actually come of it. I think the other piece of it was where we've tried to automate workflows as much as possible is with the one integrate tools, where we can provide a CAD data set, and whether it's an as-built, let's say, and instead of having to put analysts' eyes on manually going through and looking through that data, you can extract all of it from that CAD data, for example. That's something that I would like to do in the future. And it's a matter of getting our ducks in a row internally to get a steady supply of all those CAD records right now, because that's still something that is challenging because it comes from multiple sources. So I'm all ears for using AI. It's just a matter of I haven't seen any it's just not quite there yet.
Excellent. I know it's also an area that we at AppGeo are keeping a close eye on as we touch on a lot of different projects, from imagery to LiDAR to you name it, where these are emerging fields for AI and ML. Moving on, if we don't mind, Peter, another question: is there a public interface to access the ADOT MIRE data?
I'll let Patrick tackle that one.
Yeah, absolutely. So we have a statewide data clearinghouse called AZGeo. So you can search that on your Google. All of ADOT's data is on the open data portal portion of it. And so, all of our roadway characteristics data, our route network, plus our MIRE-centric items like junctions and junction legs, it's all on there and shared publicly. So you can go and you can download it and view it. And yeah, and then if you have questions, feel free to reach out to me and I can help answer any questions. But yes, it is publicly accessible right now. And again, future things we'd like to do is, right now it's essentially an annual copy of the data. Eventually, I would like to be more service-based, so that way as changes occur on my side, that update can happen more readily and not just be an annual update, but more of a build it once and just let it be.
Excellent. We have, I think, 3 more questions to get through, so keeping Patrick and team busy here. Have there been cases where the current available MIRE data has been successfully used for safety management systems, such as the HSM or IHSDM in Arizona?
Yeah, absolutely. So I work very closely with our traffic safety team, and they are leveraging our junctions and our junction legs right now for the purposes of all their analytics. And they've actually been a great partner because they have actually helped work with us to cleanse some of the data. They haven't always necessarily been a GIS team, but they've been willing to learn. And so we have taught them GIS and then they have run with it from there. And so that's kind of the GIS advocacy thing that I'm talking about. If you're willing to learn, we're willing to teach. And so with that, we're filling in some of the blanks related to some of these data elements, and then helping these other teams, answer their data questions.
Absolutely. Spreading the geospatial love all around the world, right? Last couple questions here. Someone says, great presentation. I agree. Seems like the project continued to evolve over time. What was the most surprising benefit that has come out of the project so far?
Got to be for you, Patrick.
Yeah, I guess that would be for me. I think for me, I've spoken a few times about data visualization related to this, and that's kind of been a side project and being able to have that data available to DynSeg and process has opened up such a huge role for us. It's put a whole different set of eyes on our data and improved our data quality so much. And as a state, we're really trying to focus on processes, and it's really helped identify a lot of the pain points related to our data and really brought out a lot of our skeletons, if you will, that we've then been able to identify and then say, okay, let's put some targeted efforts towards these things. And sometimes it's felt like a whack-a-mole. I fixed one problem and 3 more pop up. And so it for me, I think that the biggest surprising thing has just been the amount of data that we have as an agency, and how we're starting to gain traction as far as good data management practices. And this thing that once was very nebulous is starting to become a lot more clear to me now about what needs to be done.
Great answer. So we're officially in the overtime portion of our game here. And thanks to everyone who stayed on to the very end. We have one last bonus question here. Maybe Peter can take a stab at it. Could you explain the concept of a route network as a service? There could be a whole new webinar topic right there, but
a route network
as a service. I assume maybe that's like a Esri hosted service.
I can answer that, Patrick.
Yeah.
Yeah.
you get
So
it.
so what I'm envisioning with that is, there's a project that's ongoing right now where we work very closely with our local agencies to unify their roadway center lines, and so and that is there to directly support the Arnold, development of the Arnold network. But as far as, again, sustainability and ease of use, right now that supply chain, it comes to us, but then it's not as easy to serve those changes back out to our local agencies. I'd like to mitigate that by developing a feature service that's a direct connection into the database, a read-only, if you will, that would allow our local agencies to view the data within GIS, within Pro, what have you. So as changes on my side occur, we add a new roadway, we realign a route, what have you, they see that change almost in real time. And then that way they're leveraging the same network that I'm leveraging, and we're essentially comparing apples to apples related to these networks. And when you can do that, you're now comparing and analyzing data using the same location within time and space. To be able to do that would be a huge step in the right direction as far as good analytics from around the state.
Awesome. Well, thank you, Patrick, for all the in-depth answers there. Peter, would you like to close us up for this afternoon?
Sure. Yeah. So thank you everyone for attending. I think on behalf of AppGeo and Works Consulting and Arizona DOT, we're really thankful for you all being here, and hope you learned a lot. And if you have any questions, you have our emails, and feel free to reach out anytime. And with that, have a great day. All right.
Have a good one, everybody.
Thank you, everybody.
Everyone.